So now that we've had lots of practice at creating systems of equations from word problems, let's take a stab at, or let's have a look at solving those systems, first of all by graphing. So linear systems can be solved by graphing both equations on the same grid. If the two lines intersect, the coordinates of the point of intersection are the solution to the system. What that, in fancy terminology, in simple terminology, it means where the two lines cross, well, that's the solution. That coordinate point where those two lines intersect, that coordinate point would be a solution to the system, which means if we took those coordinate values and put them into both equations, it would satisfy both equations. So let's have a look at our example here. Solve the following system by graphing. X minus y is equal to 3 and 4x plus 5 is equal to 30. It says to use x and y intercepts to graph each line. Well, if you can graph a line by x and y intercepts, or by slope intercept, or by point slope, and it doesn't tell you, or by a table of values, and it doesn't tell you how to graph a line, then pick whichever method you choose or want to and graph your line. If it does specify though, and in this case it does, it specifies using x and y intercepts, then you need to do that, because it's that kind of work that I'd be looking for, or that the textbook or whomever would be looking for, to make sure that you're able to follow that process. So here's our first equation. X minus y is equal to 3. And we need to solve using x and y intercepts. I know that if I'm looking for the x-intercept, that I need to substitute y of 0. So y is equal to 0. I take my equation, substitute in 0 for y, and solve. That gives me a coordinate point of x of 3, y of 0. There's my x-intercept. I do a similar calculation to find my y-intercept. Oh, you know what? I'm going to change colors just because I can. Change colors for my y-intercept, except this time I know x has to equal 0. I take my original equation. I substitute my 0 in. Whoa. Whatever that was. Oh, that shouldn't be a 0. This should be a 3. Gives me negative y is equal to 3. I have to divide by negative 1. Divide by negative 1. Y is equal to negative 3. So my coordinate point is 0, negative 3. And I can plot that point and draw a line. So 2 points, 2 points, 2 points to plot. 3, 0, and 0, negative 3. 3, 3, 0. 0, negative 3. I gotta try and kind of get this a little bit accurate here. So I'm gonna go like this. And there's my line. So this equation work for x and y intercepts is for the blue line. Now I do the same process for my other line. I'll do this whole one in purple. 4x plus 5y is equal to 30. 4x plus 5y is equal to 30. If I'm looking for my x-intercept, I know y is equal to 0. I think that's what that's supposed to say. I substitute in 0. I'm going to write down my equation. Substitute in 0 for y. Continue to calculate. Divide by 4. X gives me 30 over 4. Can't really plot a fraction, so I'm going to calculate that to 7.5. So 7.5, comma 0. Coordinate point 1, my x-intercept. I do a similar calculation to find my y-intercept, except I know that x has to equal 0. Start with my equation. 4x plus 5y is equal to 30. Substitute in 0. Simplify. Divide by 5. Divide by 5. Y is equal to 6. 0, 6. That's my other coordinate point. There's my y-intercept. Plot those points. 7.5, 0, and 0, 6. 7.5 and 0 and 0, 6 fall right there. Again, I'm going to try and get that semi-accurate. You know what, I'm just going to start my line here just to make it simple for me. And there is where they crisscross, except I screwed something up. What did I do? Oh, that's not 7.5. 6. It's 6.5. 7.5 is here. There, that looks a little bit better to me. Kind of right there. And this point right here, where those two lines crisscross, well, that is considered the solution to our system. Well, what are the coordinate values of that point? 5, 2. So according to the analysis that we've done, we've graphed both lines, we've graphed them on the same grid, we found where they've crisscrossed. The point of intersection is the solution. The solution is 5, 2. Well, in order to make sure that we have the right point, we verify that. So use the point 5, helps if I'm on a pen, 5, 2 to see if it makes both equations true. So I take that value of x and y and I substitute it into my first equation. X minus y, oh no, not 5. X minus y is equal to 3. Substitute in my x and y, that's 5 minus 2 is equal to 3, which is 3 is equal to 3, which is true. So far so good. Then I take it and put it into my second equation. 4x plus 5y is equal to, what's it set, 30? 30. Substitute in my x and y, 4 times 5 plus 5 times 2 is equal to 30. That's 20 plus 10 is equal to 30. And I have 30 is equal to 30, which is also true. So we've satisfied both equations by finding that solution 5, 2. So that would be our solution to the system. Example 2 coming up.